Okay, guys, sorry we had some YouTube problems there, or rather some recording problems. So when last I was talking to you, we were going to go from the question right here into SPSS. All right, so let's go into SPSS. Now remember, okay, first let's get to regression. All right, so in order to do a multivariate regression analysis, you go to Analyze, Regression, Linear. Okay, always linear. Now you can see I've already set it up in here. All right, remember the outcome we want to predict is the dependent variable. So in this case, we want to predict that the percentage of state legislators that are Democrats, right? That's the dependent variable whose outcome we're trying to predict. The independent variables is basically everything else. So the thing that we think does the predicting, sorry, I'm just changing it back to its original wording. The thing that we think did the predicting, which in this case is the over 64 population, that is an independent variable. Also independent variables are all the different controls. So we say population with college degree, unemployment, and union are all controlled for. Look here in SPSS, we go back. The college, the unemployment, and the union variables are all controlled for. So I'm going to go ahead and hit OK. SPSS thinks it works. Good. Now, looking here, remember that the first thing we need to do in a regression analysis is check statistical significance. Always make sure the outcome is real before you try to do anything else. All right. So in this case, the variable that we care about is age 65 or older. Our test of statistical significance is right over here in the regression table. All right. It says 0.116. Remember, the threshold for statistical significance in this class is 0.2 or lower. So good. We have a statistically significant coefficient. All right. Now that we've established that it's real, we can start to think about effect size. Then I want you to look at the unstandardized coefficients. All right. Remember, the unstandardized coefficients of individual independent variables indicates the effect of a 1 unit change in the independent variable on the dependent variable. All right. So what that means in this case, if you have to answer this question, you go back, you see, oh, okay, we're increasing 1 percentage point in a state's over 64 population. What this is telling us is that for every 1 percentage point we go up in the age 65 or older category, we go up 1.903% of the state legislators who are Democrats. So the answer to this question is just an increase of 1% in the age 65 or older population is associated with an increase of 1.903% of the state legislators who are Democrats. The effect is statistically significant. I'll say that again, okay? The impact of a 1% increase in the percent age 65 or older variable results in a increase of 1.903% in the percent of state legislators who are Democrats variable. The effect is statistically significant. So that's easy, right? The great thing about regression analysis is regression analysis tells us, this unstandardized coefficient tells us the independent effect of the independent variable on the dependent variable when all the rest of these things are controlled. In other words, what SPSS does through statistics, all right, is it creates basically an experimental situation in which we've controlled for these 3 variables. All right. It says, look, we have 2 states. We're going to simulate 2 states. they're going to have the same percentage of college graduates, they're going to have the same unemployment rate, and they're going to have the same percent of workers who are union members. However, one of those states is going to have 1% more age 65 or older than another. So, controlling for these three factors, we see that 1 percentage point up of age 65 and older is worth an increase of 1.903% in the state legislators who are Democrats. Okay? Now, let's go to 1B. Let's go to 4B here. All right. Oh, shoot. Hold on. I got to fix some things. All right. Under the same conditions described in question 2, which will increase the expected number of Democratic legislators more? A 1% increase in the unemployment rate or a 1% increase in the percentage of residents with college degrees? Let's go through and ask. All right. So we want to compare the unemployment rate independent variable to the percent residents with college degrees independent variable. Well, let's go to the unemployment rate, okay? We go to the unemployment rate, and the first thing we check on these coefficients is statistical significance. Boom, problem, right? The statistical significance, the bullshit meter here is at 0.7. That's well above 0.2. Therefore, none of the rest of this matters, okay? If we see that an effect is not statistically significant, we cannot use this coefficient, all right? So what we would say in response to this, well, and then now let's go up and look at the college variable. College variable, okay, look, that is a nice, neat 0.118 statistical significance, okay? That's statistically significant. In order to answer this question, what you would say would be a 1% increase in the percentage of residents with college degrees has a greater impact on the expected percentage of Democratic legislators because the unemployment rate independent variable does not have a statistically significant effect. I'll say that again. A 1% increase in the percentage of residents with college degrees has a greater effect on the number of Democratic legislators in a state because the unemployment rate independent variable is not statistically significant. All right? Don't get thrown off by the fact that the unemployment rate has a higher unstandardized coefficient than the college. Okay? It would be true that if this variable if the unemployment rate variable was statistically significant, or if it were statistically significant, it would be higher, right? Because here, a 1% increase in the unemployment rate leads to a 0.84 increase in the Democratic legislators variable. A 1% increase of the population of college or higher only has a 0.761. However, that doesn't matter because the unemployment rate is not statistically significant, okay? If it's not statistically significant, if the independent variable is not statistically significant, we assume that it has no effect whatsoever, okay? That is basically zero for our concern. So this is just a question to remind you in regression analysis, statistical significance. Check it first before you go on to worry about effect size. Now, one other thing I want to show you in review on regression analysis is to remind you about the R-squared. All right? Remember, the R-squared tells us the percent of outcomes in our dependent variable that the independent variable can explain. So what we're saying here, right, is that if we know the age 65 or older, the college, the unemployment rate, and the union variables, if we know those four things, we can predict the right outcome in the Democrat state legislator variable about 26% of the time, all right? In other words, we know about these four factors tell us 26% of what we need to know in order to accurately predict the Democratic legislators variable. All right. And remember, R squareds are kind of tricky because we might initially say 26%. That's not a lot. That doesn't really get to much. But remember, with just 4 factors, if we can explain 26% of a really complicated outcome, because there's a million different reasons why state legislators or why a state might elect Democrats, right? We don't have anything about the minority population, and we know that impacts the vote. We don't have anything about the quality of the candidates in here, all right? So an R squared of 0.264 is not that bad, okay? I'm not going to give you any thresholds on the R squared. It's just important that you know that the R squared means if we know these 4 independent variables, the R squared is the percentage of outcomes that the 4 independent variables can predict of the dependent variable, okay? With that, please email, call, text, Twitter if you have any questions about any of this. The Stats Lab will go up Tuesday at 5 o'clock. It will be due Wednesday at 11:59 p.m. In the meantime, or during the actual Stats Labs itself, please feel free to contact me with any questions you might have. I'm happy to explain this stuff to you on a one-on-one basis, okay? Have a great rest of your weekend, guys. Bye.